Hi, my name is Fox. Welcome to Automation Workshop. Today we are doing tutorials for FluidSim, a software by Festo, which is mainly used for pneumatics, electro-pneumatics, and relay controls. But today our tutorial will be based on PLC. We will be doing PLC simulation using the software and connecting some relay circuits. So on our left hand side is where we will find our components when we are simulating or building our systems. Before we can do anything, we can start anything, we can start a new project by clicking on new. Then we have this page. When we are done building or connecting everything you want to simulate, we can then press play here. When we press play, then it goes to simulation mode. Well, on my previous video for pneumatics, the last part of the video I did introduce the pneumatic part of the software when we are doing pneumatic circuits, how you can use the software to simulate your circuit before you can wire it on a physical panel. So this is where you'll find your pneumatic components, things like your compressors, air service unit. You can find actuators, a single acting cylinder and a double acting cylinder. You can find your different valves. You can find so like everything that you need for building a pneumatic circuit. That's the folder that you open. Then here it's where we will get our electrical controls, things like our power supplies and everything. And here in digital techniques is where you'll get something like a PLC, and you can program that PLC using a function block programming language. These are the components for function block. Then here, when you have a physical Festo PLC, you can establish communication using EasyPort, where you can download or upload your program into a physical Festo PLC. Here it's where you can add text and things like that. Okay, so what's nice with the software is that most or each and every component you can open if you are not sure how does it work, to check its operation. Like for instance, if I take if I go to ladder symbols, because I'm going to be simulating first ladder as we are simulating PLC. If I click and drag and place here, I can then right click and check the component photo. Physically, this is how the Festo power supply looks like. If you would like to see it in the workshop, you will let me know. We can go to the P2 lab. We have most of our Festo components there. If you want to know how does it work, then you can right click and check the description. Like here they say 24 volts connection of the power supply. Alright, so let's start building and simulate our simple circuit or a simple ladder. The ladder that we will be connecting will be just for latching and delatching. Okay, I've already placed my 24 volts. Now I'm gonna place my 0 volts. Then I'll select a push button and place it, and if you can check well, let me zoom in. My button got two ports. Then if I click here and hold, I can make a connection with 24 volts, just like that. Okay, also, sorry for that, also with my the other side I can do the same, but before I can do that, I would like to add another push button which I'll use as my stop. Then I can place it here, then I can make a connection. Then I can, well, it's 24 volts minus 24 volts plus, it's a push button, it's another push button normally closed. This one is a switch, this one is a switch with both normally closed and normally open. Then this can be your contacts. Then this can be your solenoid valves, but we are not gonna need solenoid valves. And this will be our coil. This will be our off delay, TOF, time of delay, and this will be our time on delay. I'm gonna show you each of the component we're gonna need, but not all of them. Things like solenoid valves I'm not gonna demonstrate because we don't need it, but things like time delays I'm gonna demonstrate. So right now I'll add a coil to my rung 1, establish a connection, connect to my okay, and then I can make a switch, take this one here for latching, place it here, then I can make connection. I can also make connection. Okay, so for this contact to become a contact, or to understand what is its function, I have to align it with a coil. Let me start by my push button. When I double click on my push button, I can then label. Let's say this will be my start. Okay, then this will be my stop. If I double click, I'll call it a stop. Then this will be my let's say memory flag. I'll label it as my M1. Then this contact, I'll link it to M1. M1. You see, the moment I press OK, it then now change. It looks like a normally open contact in a ladder. I wanna link my M1 with a green LED. Here's the LED. You can drag and drop it here. I can then double click on it to change the color. Let's say I want to make it green. Then I can also connect it. I said I want to link it to my M1. I can then take this contact, place it here, double click on it, link it with M1. When it's linked to M1, it will become a normally open contact. Then make a connection, then I can power it. Okay, so I'm done with my first run. So let's run and see how my system will look like. When I press play, then when I press start, then power goes to M1 and my LED is green. When I press stop to delete everything, then my green is off. Okay, let's say now I want my green light to be on 5 seconds after I pressed my start button. Like I'll press my start button once and it delay for 5 seconds before my green light to be on. Then I'll have to have a time on delay. Here is my time on delay. As you can see, the description, relay with switch on delay. Then I drag and I drop. I can then right click to check how does it look like physically. Well, this is how it looks like. And I can also right click and check the description. So a relay picks up after preset time when the current is supplied and dropped out immediately when the current is removed. So this is to say your output will be on after a delay when your input was switched on or was a high. Can well also check the properties. The properties will call it our T1, so that anything that is linked to T1 will be linked to this time delay. Then I make a connection. I want my system to look nice and neat. I align it nice. Then I bring this contact again, but now I'm linking it with a time delay. So I double click, I say T1. When I press OK, then if you can check, it looks different with this one, because this one is linked with a time delay. Right, I connect, fix my rung so nice. Take this bit half. Yeah. When I press run, then when I press start, this should be on after 5 seconds. There we go. It is on after 5 seconds. The start button was pressed, but I want it to be off immediately. Then it is off. Okay. So let's say we want to make the light to be on immediately when I press the start button and should remain on for 5 seconds after I pressed stop button. So for us to achieve that, we'll have to remove this or change it with a time of delay, since we know how a time of delay works. This is a time of delay. When I place it here, then I can then connect here, align it nice and connect it. When I double click, I can then call it T2. Then I have to change this again, this one to be linked to that coil. T2 also. When I press, there we go. Then we run simulation to see what's going to happen. When I press, it's on immediately. When I press stop, it remains on for 5 seconds. Remember how a time of delay works like. There we go. Then it is off. So with Lather Logic, the software okay, this is a student version, is limited to this component. Things like counters we don't have. So for us to utilize such functions, we'll then have to use another language. The one, the function block PLC language. Then for me to demonstrate that, I will have to make a new project. Let's say new project. I will have to go to digital techniques. When I come to digital techniques, I can then right click and place a PLC. This PLC have about it got 8 outputs and 8 inputs. Well, the PLC, for it to work, it must be powered, so I need a power 24 volts. I'll then power my PLC. I want to take it a bit up because I want to power my push buttons also. Then I can give it a ground. Okay, now since I've powered my PLC, then I can start building my circuit. Let's say I wanna do, or I wanna design a project where when I press that, my green light comes on immediately. When I press stop, it goes off. I'll need a push button. Let's say it's a start, just like in my ladder, and I need a normally close for my stop. Say stop. Okay. Then I'll have to make connection and connect it to my input 1, but it looks ugly. Then I wanna align it horizontally. I'll have to right click, then rotate it let's say 90 degrees, or let me undo and rotate it 270 degrees. Yes, yeah, now it looks perfect. Just need to make everything look neat so that I won't have wires crossing all over one another. Then I have my start. I want to take my labeling up so that I can have enough room to put my stop button. Let me rotate it first. Then I have my stop, connect it, then I connect it, then take the stop sign up there. Okay, now it's rightfully labeled. I need my indicator. I'm gonna connect it to output 1. Also wanna rotate it, but for it, okay. I can then ground it. Okay, now I've connected everything. My PLC is powered. I press start, nothing happens because there is no program in this PLC. What must I do? I double click on a PLC, then it gives me a new page. Then this is where I can program my PLC. I have inputs and I have outputs. Let's say if input 1 is high, I want my output to be high also. Like if I simulate on this part. If I press this, I want my output to be high. Okay, let's see in the PLC. Let's run. If my input 1 is high, let's see what's going to happen. My light is also high. If I release, it goes off. So what must I do? I must latch my input. So I go back to my program. Okay. Then with this language function block, we're still gonna do it. I'm gonna post a video soon of function block. Let me give myself enough space. Okay. So for me to latch my Q1 successfully and delatch it using input 2, I will need an OR gate. On my OR gate, I need, whenever my output is a high, whenever either input or output is a high, my OR gate will be a high. Then I will then connect this to an AND gate. Where is AND gate? Here is the AND gate. Okay, so we know how an AND gate works. Like, for you to have a high in your output, all your inputs must be a high. So since I only have two inputs, my inputs are, it's input 1 and input 2. I'll then combine input 1 and input 2, just make a connection between these two. But if I had 3 input, it was gonna be simple, just to add the third one. Then I can then connect it to my output. Let me simulate it from here to see if it will work. If I press my input, oh okay, remember I'm using a normally closed output, so normally closed stop, so it's powered. When I press input 1, even if I release, there is a retailer, Q1 has latched itself. But when I press stop, then everything goes off. So my program looks good. Let's run on my wiring and see. If I press start, the light comes on even if I've released. When I press stop, then it goes off. Then my program works just good. At this point, I don't want to go deeper in other function blocks, things like counters, time delays, because we haven't done this language. But it's not that difficult. You'll see when we get to this stage that, let's say I want my LED to be on when I've pressed my input 3 times. I will need to have a counter for that. So here is my counter. Okay, So if I double click, I check the description. So the first port it's for reset, second one is for counting, the third one it's for direction. So I'll connect my counter here, then link the output of it with my OR gate. Then for reset, I want when the output is then on, my counter should reset so that we can start counting again when we have switched off the LED. Let's test it. So if I press 1, 2, 3, 4, 5, then you see it's 0. It reset because the moment my Q was high, it came to reset my counter. When I press stop, then everything resets. Let's go to our main circuit and see if it will work. 1, 2, 3, 4, 5. Then as you can see, my LED is on. The moment I press stop, everything goes off. Okay, let's say after 5 seconds I want my LED to be off. Let's make our LED to be green. Let me add a time delay to switch off my LED. So we will need to have we can use an on delay or an off delay. Okay, so let us use an on delay for now. Okay, whenever my let me connect it with my output. Okay, so when Q is high, then this one will start counting. Okay, and I will add an AND gate together with a stop. Guys, don't worry about the complete how complicated this may look like. When we are doing this language, you will understand, but I'll explain why I have an AND gate here. What am I trying to achieve? Okay, here I need an inverter that will change my time. Remember, time on delay output is active, is high after a delay time. So since my Q is off, so my timer won't count, and the output for a timer will be a 0, but with an inverter it will be a 1. So when it is a 1 and plus the 1 of the stop, then this end it will have a 1 as output, which will make this end to have 1 when the start button is pressed. So that's the logic. So what I'm trying to achieve is that whenever I press a stop, my Q should be off, or 3 seconds after the Q was on, it must switch off automatically. Let me demonstrate. Okay, when I press 1, 2, 3, 4, 5, see the counter is counting, then my Q is off. See, if you can check very well, my time delay, its output is off, but after an inverter it is a high. But don't worry about that, we will do this language very soon. So let's simulate it this side and see. 1, 2, 3, 4, 5. The LED is on, then it is off after 3 seconds. Okay, so there are a lot of things that you can add. Let's say you want to link your PLC with your relay circuit. Here are the relays. This is the coil of a relay. Let's say on my output 3, I'll have a relay. I can then connect the coil of a relay on my output 3. Let's say I will name it K1 because we are used to that. I must ground it. Then I want you to see the K1. Let me put it this side. Yeah. Okay. Alright, let's have a different power supply. Let's say we have 24 volts. Now we have a second circuit, a relay circuit. Okay. Let's say I want to run a buzzer. Say buzz needs a different voltage. It can then have its own power supply. Here are the switches. I'll then take this switch, make it the contact of a relay by double clicking and linking it with K1. Okay. Alright, so I must now program output 3 on my program. Let's include output 3. Okay, here's my output 3. Let's say we want our buzzer to be on when your LED is on, but remains on when your LED is off. I'll use a time of delay. If we check the description, the first port is for trigger and the second port is for reset. Okay. Right, we want to trigger output 3 by Q1, then I make connection. Alright, let me put this side so that you can see everything. Where does it comes from, or where does it go? Alright, so whenever my Q3 is on, then my buzzer will be on, but will remain on even if my LED is off, but for a short time being. Let's run the simulation. If I press 1, 2, 3, 4, 5, my buzz is let's start afresh. 1, 2, 3, 4, 5. It remained on even though my LED was off. Okay guys, so yeah, when you get the software, you can then play around everything to familiarize yourself with the software. Well, yeah, we also have the delays for relay circuits. So when you are building your relay circuit, you can then wire things like time delay. This is on delay for relay, and this is a counter for time delay. So if you check the description, if your connection is between if your connection is between A1 and A2, and you have powered or you have counted 5 times, it will then make connection between A1 and A2. So you can play around to see how relay time delays works like. Can then save your work for future, and yeah, like you, after downloading the software, you can play around it to see the things around. Thank you.